I'm Alex Paradis, and I did my bonus presentation on how much heat needs to be transferred to perfectly cook a pancake. The breakfast food industry, which is based mostly off of pancakes and waffles, is a huge part of American society as it employs tens of thousands of workers across the country. Some of the most notable ones are Waffle House and IHOP, and the motivation for this experiment is Dr. Lawrence gave the opportunity to perform an experiment and receive extra credit relating to heat transfer, and there was no reason to pass this up. The objectives for this experiment were to determine how much heat needs to be transferred to perfectly cook a pancake, as well as to calculate the heat flux. Regarding the theories and fundamentals of this experiment, well, heat can be transferred in three different modes: conduction, convection, and radiation. In this experiment, we're focusing on conduction. This is the transfer of heat from the more energetic particles of a substance, in this instance it's going to be the griddle, to the adjacent less energetic ones, which will be the pancake, and this relationship can be expressed by Fourier's law of heat conduction, and this is displayed on the screen with K being the thermal conductivity, A being the surface area normal to the direction of heat transfer, and dt dx being the temperature gradient. The heat flux equation is lowercase q dot is equal to the thermal conductivity times the temperature gradient. And the units for heat transfer are watts, while the units for heat flux are watts per meter squared. Regarding the experimental procedure, we begin by measuring out 1 cup of pancake batter with 1/3 cups of water. We would then put them in a bowl and mix them till there are no clumps. Following this, the griddle should be set to 375 Fahrenheit. This will be converted to Celsius later. Once the griddle has reached 375 Fahrenheit, we then pour a 1/4 cup of the batter onto the griddle. Measure the radius of the pancake to find the area with a ruler, and hold the thermometer in the pancake and record the temperature with the respective time. We flip the pancakes 90 seconds in, and then take it off a minute after that. The time chosen to flip it came from the box. For the results in conclusion, I ended up measuring the surface area to be around 25 centimeters squared. The final temperature of the pancake ended up being 99 Celsius, while the temperature of the griddle was 191 Celsius. The thermal conductivity of the cast iron griddle is 40 watts per meters times Kelvin, and the amount of heat transferred is around 1,740 watts, while the heat flux ended up being around 3,700 watts per meter squared. These are the websites that I got my pictures as well as data from, and I got the formulas from the single textbook we use in class. I'd like to thank Dr. Lawrence for this opportunity to receive bonus credit.